Welcome to another awesome coding day in Nuremberg, Germany. Today I talk about stacks. A stack is a very simple first in, first out memory concept, and you can basically see it here on the screen. So think of those blue rectangles as integer variables or any other kind of variable. And now we can push variables on top of this data mountain here and delete data by basically popping it. So the delete command is called pop, because pop is not only deleting the data, but you also get the data you delete. But we look at this in a concrete example. So those stack memories come in very handy for nested functions. So let's say you are in main function and the commands get executed, and then you define variables like integer x, integer y. So those variables are now pushed on the stack. So now you can say x and y are here on the bottom, and now you call some function. Let's say call my function. Yeah, and my function is executed and defines variables a and b. So now those variables are pushed also on top of the stack. So basically you have a and b now here in the middle. And then you call another function. Let's call it c. From inside my function, you call another function. So another function is doing the same. It's also defining some variables. And basically, it will push those variables here on the stack. So, okay, we have this kind of memory order now. And is it of any great use? Yes, because we will leave another function. But before we leave another function, we pop k and l. That means we delete them. We don't need them anymore. So now we delete k and l, which are on top of the stack, and we're left with a clean stack, which only has the variables for the function main and my function. So you see, it comes in very handy for organizing program memory, and that's why it's used all over the place. Like every project, whenever you program in C, you don't see it, but the meshing codes behind it always build up those stacks and delete them. So stacks are very useful, and we're going to program today a stack class. That's the goal for today. In the stack class, we'll have those functions. We will initialize the stack. We will push pop data. We will peek. So that means pop means delete data. Peek means just look up on the top element and tell me what it is. Then we have is full, or so those are just questions. Is it full or is it empty? So that's a goal for today. So we just start with the main function, integer main void. And we return with this defined variable, and this variable is defined. Let's start here. Standard lib. But of course, we want to print out stuff, so standard IO is also very useful. And now comes something new. The define statement. That's so-called preprocessor statement. And basically, before the program gets compiled, the compiler will look through all the code, and when it sees a define statement, it will replace all occurrences of 10 with the all occurrences of the word stack size with the variable 10. So we can do something like this here. And then stack size will be replaced with 10. So the good part about this is we don't have to define an extra variable and reserve memory for that. So we can just have this replacement. Okay. So let's define our struct class. And of course, we use a type def for that. So what variables do we need? We need a buffer. I'll come a bit later to that. So that's basically a pointer to a memory. We need a capacity. So stack size is basically the maximum capacity. And we need a current position. So remember, when we push data on it, we have to know where we are currently. Okay. So far, so good. So next thing is we want to implement all those functions here. So we know how to do that. We gotta define a pointer like so. And then we have to enter here the structure of the function, right? So, but we haven't defined the structure yet. So let's do this. So let's define a bunch of functions down here. So the init function. The init function might fail, so we want to return some message, like we return it here. Exit success. We want to return something here. And we want to make it a bit more explicit, so let's call it init stack, because we have no direct connection to the struct yet. So to give it a name like that. And now we want to hand over basically the stack itself. So remember, that's this pointer of type stack. Type stack. This here. Let's make it clean for now. So we hand over an object of type stack, and it's called this. So then we hand over some pointer to a storage, and this pointer will be of type integer, and we also have to hand over a size. And now comes something new. It's a data type size t. Size t is can be confused with unsigned integer because it's also a positive integer basically, but it's defined by the system, so you get it out of these include statements, and it has the advantage that it's a promise. It can store the size of any object you can possibly define on the system. So it might be the exact same data type as an integer, unsigned integer, but it's not 100% sure. So you can look up what size it actually is. But so it's good practice for any memory related stuff to use this size t statement, size t data type. Sorry. So size t size of storage. I have to make it a bit smaller. Okay, cool. So first thing is we have to check whether everything is fine. So if this is null, then there's of course an error, or this pointer to storage is also is null. Then it's definitely incorrect, and we return, let's say, -1. So could there be another error? No, I think this is fine. And now we can basically say this. buffer equals this pointer. The capacity is defined in here. This function does not know how big the storage is because it's just a pointer to an integer, and we don't know how many integers are stored there. And of course, the current position is 0. And note, it points. This is position 0 here, right? And this position 0 has not filled with any relevant data. So position points to the next element, which can be filled with useful data. Remember that. There's still no useful data inside. Okay, and then we can return. Let's see. Okay, cool. So what we can do now, make this a comment for now. What we can do now is we can define an object like, let's say stack, my stack. This works already. And now we can define this function init stack here. Pointer, let's call it init. And the function is of this structure. And we don't need the variable names. And this should be fine. This should be fine. Now we defined my stack. Now we can define an array. Let's call it integer memory 100. Of course, it's stack size. And now we have to assign to this init variable the function init stack. Okay, this should work. So let's try this out. mystack.init is the address of my stack. Then we hand over the memory, which is implicitly converted to the pointer. And then we hand over the stack size. And those capacity should also be of size t, and positions should also be of size t. It's not so nice here. Overall, it could be right. So how to read? So unknown type stack. This is not good. Let's make it like so. So of course I forgot to implement the forward declaration, so I gotta do this now. Remember that we use stack here, although stack is currently defined but not yet ready. So we gotta make this promise here. We will define it properly. Oh, it works nice. Okay. And now we should print out some data like the capacity and the position. And it's of type size t, and size t is printed out with LD. So capacity and position. can make it a bit nicer. So that works. Nice. So we defined capacity through this function here, through this init stack function. And now we can go on with the other functions. So let's call it push stack. So we push data on the stack. So we need, again, our this variable. And we have to add the value we want to push. So again, we have to check whether there's some error. And we have to check whether whether this capacity is this position. So in that case, the stack is just full. And this should be okay, I think. And now we can this position. So we can write this position +1, but we can also write it in short. And the short way of writing it is doing something like this, just ++. And now we can assign at the position the value we want to put here. Oh no, this is incorrect. Position already points to the next. So remember, currently when we initialized it, position is already 0, but 0 is not a meaningful value. So the first meaningful value we put on the stack is at position. So 0 becomes value, and then we increase position. Okay, and then we can return with 0. Everything is fine. Okay, and then we can also implement pop. Oh no. Oh, what's happening? Of course, we need our this pointer. And you might say that's it, right? Because we just want to push, want to pop the top element, and we know it by it's at position -1 currently. So let's ask again if this. But we also have to check whether is 0, because then there's nothing to pop, right? Then it's already empty. Oh. And otherwise, it should be fine. And then we say now we decrease it by 1, but given the logic that position is always pointing to the next unused valid position, I should yeah, we want to no, it doesn't make sense. Do this first, and then we return this position. So, but this is a problem because we cannot differentiate between -1 and -2 and whether this might be a valid value stored at this position here. So what we're gonna do now is we hand over a value, a pointer to a value, and we return just our oops. We return just our success value, and what we do here is we change value. So the content of the variable value of the pointer value is changed or is replaced with this so that's the data, and the data is located at position -1, right? So that makes sense. So position points to the next element, which is currently unused. -1 is the top element, and this is assigned to the data where value points to. Okay, and then we reduce the position, and then we return, and this should be fine. So pop stack, and now we can do peek. So can we have error values? Yes, we can. So we should hand over another value. And then we have to check again for is empty. And then we can just return but we don't reduce this position here. Instead, we just return 0, right? Basically, that's the difference. And you might say, can't we do this smarter? So it's called integer okay. So now we're checking whether this is just empty, and we just hand over our pointer. And because there can be errors, we gotta also hand over some value, and this value can be of type bool, so Boolean true or false. So again, we just, and you see we copy the same code all over the place, and maybe it's better to structure the program a bit different. That's called the dry principle. Don't repeat yourself. So is stack empty, and then we return if this. So when we execute just one command after if, we don't need the brackets. Okay, is stack empty, and then is stack full, and I just copy it. if position is this. Okay. This should be fine. And now we implemented all those functions here. This should work. And yeah, so we're checking here for whether the stack is empty or not. And we might simplify all those things, but I don't know, maybe this is better for another video. So let's play with our stack. So does it compile? Yes. No. Of course it's called stack. Unknown value. Push stack integer value. Okay, cool. So now we just have this single function, this init function, but of course we need all of them. So I think we have 7 functions. I'm not quite sure. So init stack. We've got push, pop, peak is empty and is full. Oh no, we only have 6 functions. Yeah, okay. Looks good. So let's copy this entire thing here. Hopefully it's easier to read then. So we got to run through those definitions here now. So we have, let's copy this. Push, pop, peak. Gotta check whether I recall those names properly here and whether I use them as intended. Push stack, okay, cool. Let's go through this. So we have init stack, push stack, pop stack, peak stack. Is stack empty? Is stack full? Okay, that's nice. So one thing more, we have this init function here. So we gotta copy those ones too. Push. So this, now you see that professional IDEs might be of great use because we're copying a lot of stuff here, and those things really help you to do it properly. But I used to be reluctant to use them here in those videos because I thought it's a bit peak stack. What did I copy? Because I thought it's a bit too overwhelming to have such an IDE, and I don't know. So is empty. Is full. Okay, so we have this definitions hopefully correct. And now we assigned already the functions. Should be fine. So I don't know, let's just compile it. 52. Position is undeclared. Oh yeah. Cool. This looks nice. I just redefined it here. This doesn't make sense. Okay. So now we can play around. And we can push, of course. Now we can pop them back, but remember we have to hand over a variable. And this, it was called value, so just hand over value, or some other my value. Of course we can choose any name we like. And then we hand over only the address of it. So we build up the stack and we unwind the stack. And of course we can then print out our return values. So let's say integer my value, let's say is 0. So we can print out my value. So okay. Just print it out each time we receive it. Something's wrong, definitely. Passing argument 1 of my stack push makes pointer from integer without a cast. Stack push stack integer value. I don't get the point currently. My stack push to a few functions. Ah, my gosh. So in Germany, we say who can read is clearly has the advantage. My value. I think I did the same mistake here. Push pop my value. Yeah. Poop. Pop. Okay, cool. So first I push 52, 42, and 23 on the stack. So 23 is on top, and below 23 is 42 and below 52. So, and that's what we see here. So we pop back first 23, then 42, and then 52. Of course, position is currently 0 because we popped everything back. So we can push those values another time. And then we should see position is 3. Nice. And then we can check for is empty. And it's my stack. So here the stack is empty, right? So we haven't pushed anything yet. It's empty, my stack, and we have to hand over also a variable. And then we can print out is empty and print out my value, correct. Oh, of course, you must define values only once. Ah, passing we're passing 2 arguments is empty from incompatible pointer type. Oh, how did I define this function? Stack, bool, okay, yeah, bool value, alles klar. So this doesn't make sense here, so let's my bool is false. And we hand over, well, let's say it's true, because we want it to be set by the function. No, that's a false. This one. So now it should be true when we come back here from my stack. And yes, we have to typecast it. No. My stack is empty, my bool, we hand over. Oh, come on. Okay. So is empty is true at this position. And now when we pushed our first data, of course we must not redefine it. Then is empty is false. So seems to work. I didn't test out all functions, all edge cases, but that's what you got to do. And basically that's it. So we built a stack class. Everything we learned came together, I think, in this video. So well, I think it's a nice example. So we will use this understanding from now on when we look into the meshing codes, and this is very important and very substantial. So yeah, I hope you enjoyed it. See you soon and stay awesome. Ciao.